Wow, look at this place. A rainbow of flowers, blooming and dancing in the sunshine. Isn't nature just buzzing with beauty? And guess what? None of this would be here without some tiny, winged heroes, the bees. Buzz, buzz. Hello, my little friends. I'm Professor Zapnik, the world's greatest and buzziest bee professor. Put on your bee wings, because we're about to dive into the wonderful world of bees. Look at these little wonders. How hard they work, flying from flower to flower, collecting nectar, without ever taking a break. Incredible, isn't it? Such tiny creatures, doing such big jobs. See its body? It has three main parts: the head, the thorax, and the abdomen. Like all insects, it has 6 legs and 2 pairs of wings. And those wings, they beat so fast, they make that buzzing sound, up to 230 times per second. That buzz, to me, that's the music of nature. This right here is a beehive, like a bee city. Did you know a single bee family can have up to 60,000 members? That's like a soccer stadium, but with honey and pollen. Everyone has a job. Meet the crew. That's the queen. Nope, not a Disney princess. She's an egg-laying factory. She can lay up to 2,000 eggs a day. She holds the whole family together. Worker bees, all girls. They collect nectar, build the hive, clean, guard the entrance. They do everything. Drone bees, the boys, their one job? To fall in love with the queen. But just once. Then, it's a short career. Oh, hold on to your flower petals. A worker bee only lives for 5 to 6 weeks, but in that time, she works harder than a kid doing 20 math tests in a row. The queen, on the other hand, can live up to 4 or 5 years. Well, being queen has its perks. Now comes the sweet part. Honey doesn't just fall from the sky. Here's how bees make it. A bee lands on a flower and sucks up nectar with her straw-like tongue. She stores it in her special honey stomach, not her snack tummy. She flies home and passes it to another bee, mouth to mouth, bee style. It gets chewed, processed, dried, and dropped into a honeycomb cell. Bees fan it with their wings to dry it so it won't go bad. Then they seal it with wax caps, like tiny honey jars. And voila, honey. Honey is nature's candy. Bees visit around 2 million flowers to make just 1 jar of honey. That's why we say, every drop is a treasure. Honey is a superfood. Let's take a look. Natural sugar, quick energy, antibacterial, helps with sore throats and colds, packed with vitamins and enzymes, like a sweet vitamin snack, heals wounds. People even used it on cuts in the old days. But remember, only eat honey if you're over 1 year old. It's not safe for babies. Did you know that pollination is the bee's superpower? Bees don't just make honey. They're the world's best gardeners. They pollinate flowers, helping them grow fruit. That's called pollination. No bees, no apples, no strawberries, and yes, no chocolate either. Cocoa flowers need pollinators too. But sadly, my little bee buddies, we've got a big problem. Bees are in danger, and when they're in trouble, we are too. Why? Let's see. Pollution from factories and cars. Smoke, dust, and dirty air make it hard for bees to fly, and flowers produce less nectar in polluted air. Too many pesticides. Farmers spray lots of chemicals on crops. These poisons don't just hurt bugs, they poison flowers and bees along with them. Flower meadows are disappearing. Cities, roads, and buildings are taking over the land where wildflowers used to grow. And flowers? That's bee lunch. Climate change. Too hot, too cold, too unpredictable. Bees get confused about when to come out, and often end up without enough food. And guess what? In some countries, 1/3 of all bees have already disappeared. If this continues, we'll have fewer fruits, vegetables, even chocolate could be in danger. But don't worry, there's hope. And you can be part of the rescue mission. And what can we do? The Buzz Buzz Plan. Plant flowers. Bees love lavender, sunflowers, and phacelia. The more flowers, the more bee-happy places. Even a balcony pot makes a difference. Avoid chemicals. Say no to pesticides. Try natural solutions like nettle tea or cinnamon to keep pests away safely. Buy local honey. Support nearby beekeepers who care for bees. Plus, local honey is healthier and tastier. Spread the buzz. Tell your friends, your family, even your teacher why bees matter. Every voice helps, because if bees live, so do we. All right, little bee rescuers. Now you know that without bees, we wouldn't have so many things we love. Flowers, fruits, honey, even chocolate. So go out there and spread the message. Save the bees. Let's buzz and protect together. Oh, that reminds me, little friend. Did you know bees can dance to talk? When a bee finds a yummy flower, she flies back to the hive and throws a buzzing disco party. This is called the waggle dance. And it's one of the most amazing things in all of nature. Ah, and the hive. Did you know this is where bees store their honey, where baby bees grow up, and where the queen lives too? Bees keep everything tidy, clean up, warm the hive, and even make air with their wings. It's like a real mini bee universe. When we protect the bees, we protect life. The flowers, the food, the planet, and our future too. They take care of the planet. Now it's our turn to take care of them. Buzz, buzz, and see you in the meadow, my friends.
Ladies and gentlemen, boys and girls, get ready for the brilliant, the wacky, the master of plant science, Professor Zapnik.
Hello, kids. Today we're going on a root-tastic, leaf-tastic, chlorophyll-tastic adventure. We'll discover how a tiny seed becomes a big leafy plant. This isn't just a boring brown dot. Oh no! This is a plant in a pocket. Small now, but it holds leafy dreams. Inside is a tiny baby plant, an embryo, just waiting for the perfect moment to wake up and grow. Now, let's plant our seed. We gently tuck it into the ground, but not just any ground. Oh, no, 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 no. It has to be rich, nutritious soil, full of minerals, bits of old leaves, tiny bugs, and other tasty stuff that plants love to snack on. This is the perfect home for a seed. Cozy, dark, moist, like a little underground hotel suite. But the seed doesn't do anything yet. It's waiting for something important. And that something is water. Yes, first, the seed needs water. Lots and lots of it. When the seed drinks up the water, it's like you washing your sleepy face in the morning. It wakes up! The water starts chemical reactions that turn on the plant's grow now. Switch. Enzymes wake up. Energy is released. And the seed begins to stretch and grow. The seed coat, that hard shell on the outside, softens and cracks open. And then, the embryo inside gets to work. The first thing to pop out is the radical, that's a fancy word for the baby root. It grows downward, deep into the soil, searching for more water and food. It grabs on tight so the plant won't fall over later, and it starts slurping up water and nutrients. Delicious dirt juice. So now the seed is awake, drinking, growing, and ready for the next big step, reaching up to the sky. It's time to move. The plant stretches, twists, and begins its climb to the surface. Introducing the shoot. This little green stem is on a mission. It's heading up, 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 straight toward the light. It's like the plant is saying, "Where's the sun? I need to photosynthesize already." And ta-da! Look who's here. The cotyledons. The plant's very first leaves. Some plants have one, some have two. Depends on the species. These starter leaves are super important. They help the baby plant get its first taste of sunlight. And now, it's time for the moment we've all been waiting for. The sun. With sunlight, the plant can finally start photosynthesis, making its own food like a mini chef. So we've got roots below, shoots above, and leaves reaching for the sky. The plant is now officially alive and growing. Now that the little plant is above ground, with its leaves soaking in the sunshine, it's time for the big stuff. It's time for photosynthesis. Inside the leaves are special teeny-tiny kitchens called chloroplasts. They're the plant's very own chefs. Photosynthesis is a big word, but it's a simple idea. Plants use sunlight, water, and carbon dioxide from the air to cook up their food. The sunlight gives the energy, the water comes up from the roots, and the carbon dioxide gets slurped in through tiny holes in the leaves called stomata, like little plant nostrils. Out comes glucose, a kind of sugar. That's the plant's lunch. And the best part? As a bonus, the plant releases something amazing: oxygen, the same stuff you breathe every single day. So while the plant makes its own food, it's also helping the whole planet. Plants really are like green superheroes. So now our seed has become a baby plant, feeding itself with sunlight, slurping water from its roots, and breathing with its leaves. It's not just growing, it's thriving. Now the plant grows bigger and stronger. Some become trees, some bloom into flowers, and some grow tasty veggies. And when it's ready, it makes new seeds, and the whole cycle starts over again. All right, my little scientist, you've learned one of the biggest secrets in plant science. But before we say goodbye, let's go over it one more time. What does a seed need to become a plant? Water, sunlight, soil, warmth, air, and of course, a little time, and lots of love. That's it. Well, maybe a tiny bit of plant magic, but nature takes care of that. Now you know the amazing secret. Every plant, big or small, started out as a teeny tiny seed. It could grow into a flower, a tree, or a jungle in your bedroom. Careful with that. Remember, nature is full of wonders. Just stop and look under a leaf. Plant one, watch it grow, and be amazed by the power of nature. See you on the next big discovery. And remember, stay curious and never stop asking questions. Bye for now, junior scientists. I'm Professor Zapnik, the master of all things green. Bye. Important. Very important. Hand washing, bacteria, soap. But wait, do you know what a bacterium is? Hello, my little scientist friends. I'm Professor Zapnik, and today we're going to answer a super exciting question. What is a bacterium? Bacteria are tiny. So tiny, millions can fit on just one fingertip. Some are helpful, like the ones that live in yogurt. We sun, and others help your tummy with digestion. Good bacteria, like probiotics, are tiny bodyguards in your belly. They help you digest food, fight off bad germs, and keep your immune system strong. Without them, your tummy might grumble more and not work as smoothly. But some bacteria like to cause trouble. They sneak into your body through dirty hands or spoiled food, and once inside, they throw a real mess. They can make you cough, give you a fever, or upset your stomach. That's when your body starts fighting back. Luckily, we have a real superhero: soap and hand washing. Bacteria are everywhere on your fingers, the doorknob, even your pizza. But you can be the one who knows what to do. Wash your hands, eat lots of fruit, and if you're sick, rest well. Your immune system needs the energy. Soap is a true superhero against germs. When you rub your hands with water and soap, the bubbles surround the bacteria and slide them right off your skin. Just a bit of soapy water, and off they go, down the drain. But if a bacterium sneaks into your body, don't worry. That's when your immune system, your body's brave defense team, jumps into action. They recognize the intruders and fight to keep you safe. They're like an invisible shield, watching over you every day and protecting you from getting sick. That's all for today, little scientists. Don't be scared of bacteria, just get to know them, because knowledge is the real superpower. Here come the bubbles, chasing the bugs. Soap dance magic with scrubs and hugs. Scrub and rinse, and soon you'll see clean hands make a hero out of me. Hello, young scientists. I'm Professor Zapnik, and I love plants and colors. Today, we're solving a mystery. Why do leaves change color in the fall? Leaves are green in the summer because they're full of chlorophyll. That's a green pigment, but also a superpower. It helps leaves do something amazing called photosynthesis, turning sunlight into energy for the tree. So, what's really happening during photosynthesis? Well, the leaf takes in sunlight from the sky, water from the roots, carbon dioxide from the air. And inside the leaf, in those tiny green chloroplasts, the chlorophyll mixes them all together. The result? Sugar, which the tree uses as food, oxygen, which goes back into the air for us to breathe. So, sunlight plus water plus carbon dioxide turns into sugar and oxygen. Pretty awesome, right? Leaves are like tiny green power plants, but as fall arrives, the days get shorter and cooler. The trees start to shut down their food factories. Less sunlight means less photosynthesis. When photosynthesis stops, chlorophyll breaks down. That's when we start to see the hidden colors that were always there underneath the green. It's like the green curtain gets pulled back. And surprise! Inside the leaf was a whole rainbow of colors, just waiting for their moment to shine. Yellows, oranges, even a little bit of gold sparkles sometimes. Leaves also contain other pigments, carotenoids, which make those bright yellow and orange colors, like bananas, carrots, and pumpkins. And xanthophylls, which add a soft golden yellow glow, like sunlight peeking through fog. These pigments are always in the leaf. All through the summer, they're just hiding behind the strong green of chlorophyll. Once the chlorophyll fades away in the fall, the other colors finally get their chance to perform. These pigments are always in the leaf, but you only see them once the green fades away. But some trees go even further. They make red or even purple pigments in the fall. This new pigment is called anthocyanin. Anthocyanins help protect the leaf from sun damage and pests, while the tree reabsorbs important nutrients. And which trees do that? Let's look at some superstar color changers. The red maple turns bright red like fire. The dogwood tree, its leaves can go deep burgundy or wine purple. The black tupelo shows off with scarlet, orange, and even purplish tones. The sweet gum tree, it's like a rainbow. Red, purple, yellow, all on one branch. And even some oak trees, especially the northern red oak, turn dark red or rusty crimson. Pretty cool, right? Anthocyanins help protect the leaf, kind of like sunscreen and bug spray in one just before the leaf's job is done. Once the tree has taken back all the nutrients it needs, the leaf's job is done. It dries out and falls to the ground like a final bow at the end of a performance. But wait, that's not the end of the story. On the forest floor, those fallen leaves become something amazing. They slowly break down and turn into rich, dark soil called humus. That soil is full of nutrients, which help new plants grow in the spring. So even though a leaf may be dry and brown, it's still helping the forest. It's like the leaf is saying, "Okay, I fed the tree, now I'll feed the ground." The forest recycles everything, nothing goes to waste. So, my curious little scientist friends, why do leaves turn red, yellow, and orange in the fall? Not magic! It's science in disguise! The green comes from chlorophyll, used for photosynthesis. In fall, chlorophyll breaks down. Yellow and orange pigments, carotenoids, xanthophylls, are revealed. Red pigments, anthocyanins, are made fresh. The tree gets ready for winter, and the leaves fall. That's how nature creates its most colorful show of the year. So next time you see a red or yellow leaf, remember, it's not just pretty, it's science in action. See you next time for another leafy adventure. Bye-bye. Hello, young scientists. Today, we're going to explore something truly amazing, something every green leaf does every single day. It's called photosynthesis. This is the process that helps plants grow and lets us breathe. Let's take a closer look. Even closer. Even closer than that. This is a plant cell inside a leaf. And right here is where the magic happens. Inside, the cells are tiny green parts called chloroplasts. Each chloroplast contains chlorophyll, a special green pigment. Chlorophyll is amazing. It can capture energy from sunlight and turn it into a form the plant can use. Sunlight energy is our first ingredient in the recipe of life. But sunlight alone can't make food. We need two more raw materials. Water, pulled up from the soil, carbon dioxide, taken from the air. Without these, photosynthesis wouldn't work. The plant needs all three, like a chef needs all the right ingredients to bake a cake. Deep in the soil, the plant's roots are busy at work. They absorb water molecule by molecule through tiny root hairs. This water moves into the plant's xylem vessels, tiny tubes that act like straws, carrying water upward through the stem. The water isn't just for drinking, it's one of the main building blocks for making sugar during photosynthesis. It will be split into hydrogen and oxygen later in the process. Now, let's meet our second raw material, carbon dioxide. It comes from the air all around us. Yes, even the air you're breathing right now. The leaf has tiny openings called stomata, singular, stoma. They work like adjustable doors. When they open, carbon dioxide molecules slip inside, and oxygen and water vapor can exit. Once inside, the carbon dioxide heads toward the chloroplasts, ready to be used. Here comes the magic powered by science. The chloroplasts use sunlight to power a chemical reaction that transforms water and carbon dioxide into something amazing. Chlorophyll captures sunlight, which energizes electrons. This energy is used to split water into hydrogen and oxygen. The hydrogen and tiny energy packages stay inside the chloroplast, ready to be used in the next step. The plant uses the stored energy and the hydrogen to combine with carbon dioxide. The result? Glucose, a simple sugar the plant can store or use for energy. Scientists like to write photosynthesis as a chemical equation. Let's take a look at exactly how that works. 6 molecules of carbon dioxide plus 6 molecules of water plus light energy become 1 molecule of glucose and 6 molecules of oxygen. This equation is like the recipe for life on Earth. It happens billions of times a day in leaves all over the planet. Photosynthesis is the foundation of almost every food chain. Plants make sugar using sunlight, and that sugar becomes food for animals and humans either by eating the plants themselves or by eating animals that fed on plants. The oxygen produced by plants fills the air so animals can breathe. In return, when animals breathe out carbon dioxide, plants use it again, completing a beautiful cycle. Even though photosynthesis is a wonderful process, it doesn't always work perfectly. Let's see what can slow it down. Too little light, without enough sunlight, like in deep shade or during winter, the plant can't capture enough energy. Not enough water. During droughts, or when the soil is dry, the plant can't get enough water to make its sugar. Low carbon dioxide. There's usually carbon dioxide in the air, but in closed spaces or polluted environments, it can be too low for healthy photosynthesis. Low carbon dioxide. There's usually COR in the air, but in closed spaces or polluted environments, it can be too low for healthy photosynthesis. Extreme temperatures. Too cold and the process slows down. Too hot and the plant's enzymes can be damaged. Air pollution and dust. A layer of dust or pollution on the leaves can block the stomata, making gas exchange harder. That's why plants need the right place, with plenty of sunlight, water, and clean air so they can produce lots of oxygen and food for the planet. Photosynthesis isn't just plant business, it's everyone's business. Without it, there would be no green forests, no fresh air, no humans, no animals, no delicious fruits, nothing. And maybe plant one yourself, you'll be helping the planet breathe. Bye-bye. Hello, kids! It's me, Professor Zapnik, the world's biggest butterfly fan. Today, we're going on a magical adventure to discover the colorful, fluttery life of butterflies. A butterfly is actually an insect. Yes, an insect. Did you know that? It has 6 legs, 2 antennae, and, listen carefully, 2 pairs of wings. These wings aren't painted. Oh no, they're covered in tiny scales, like a flying mosaic. The way they reflect light is what makes them so colorful. Now watch closely. It's time for the miracle. A butterfly doesn't start out the way you think. First comes an egg, then a caterpillar, and it eats, and eats, and eats. Then comes the chrysalis. It looks like it's sleeping, but inside, it's transforming. And finally, ta-da! A beautiful butterfly. This is what scientists call complete metamorphosis. Jungle, meadow, desert. mountains, different butterflies in each place. Butterflies live almost everywhere. Forests, fields, even deserts. All they need is warmth and flowers. Butterflies aren't just pretty. They're pollinators. They help plants grow by spreading pollen from flower to flower. No butterflies equals fewer fruits and flowers. Did you know? Some butterflies can taste with their feet, and others migrate, flying thousands of kilometers, like the famous monarch butterfly. Butterflies aren't just science stars. People have always loved them. They show up in fairy tales, paintings, and some cultures believe that if you see one, it brings you luck. So, my little scientist friends, butterflies are more than just pretty wings. They're real-life nature wizards. Next time you see one, say hi. It might be a caterpillar you once knew. And remember, science equals adventure plus curiosity. I'm Professor Zapnik, and I'm fluttering away. Bye-bye. Did you know that the world's largest structure wasn't built by humans, but by tiny, squishy little monsters who actually hunt at night? Welcome to my lab. I'm Professor Zapnik, and today I'm taking you to an invisible empire that is simultaneously a hardcore engineering feat, a lazy sublet, and one of the planet's most vital life insurance policies. Many people think corals are plants because they're colorful and stay in one place, while others mistake them for rocks due to their hardness. But the truth is, a coral is an animal. More specifically, it's a tiny creature called a coral polyp, which belongs to the phylum Cnidaria. Although the name sounds similar, don't picture an 8-armed giant octopus. These creatures are minuscule and are more closely related to jellyfish. However, this soft, cylindrical creature doesn't leave things to chance. To protect itself from predators, it builds a solid limestone skeleton around itself, using calcium carbonate extracted from seawater. This process is one of nature's most mind-blowing tricks. Imagine if you could turn your own sweat into an impregnable fortress. When an individual dies, its limestone skeleton remains for posterity, and new generations simply settle on top of their ancestors' remains. Over thousands of years, they build monumental reefs, the largest of which, like the Great Barrier Reef, can be seen even from outer space. Behind the magical colors of corals, however, lies a tough business deal called symbiosis. Inside the tissues of these tiny architects live microscopic, single-celled algae called zooanthellae, which have signed nature's most brilliant rental agreement. The coral provides a safe home and carbon dioxide for the algae, while the algae photosynthesize using sunlight and hand over the resulting sugar, pure energy, almost entirely to the host. This partnership covers nearly 90% of the coral's energy needs, which is why they require shallow, crystal-clear waters, where sunlight can still reach these solar-powered residents. Although corals hunt tiny plankton with their tentacles at night, that's actually just a little midnight snack compared to the sunlight-based main course. This idyllic state, however, is extremely fragile, and here we arrive at the tragedy of corals: bleaching. When ocean temperatures rise by even just 1–2 degrees Celsius for a prolonged period, the corals get stressed and, in a sort of biological panic, evict the algae. Since the algae provided the colors, the coral becomes nearly transparent, revealing its white limestone skeleton, hence the name. Without the algae, there is no energy supply. The coral begins to starve, and if the water doesn't cool down in time, the reef simply dies of hunger. This process is compounded by ocean acidification caused by the absorption of atmospheric carbon dioxide. In more acidic water, these tiny master builders are physically unable to construct their skeletons because the acid simply dissolves the building material before it can solidify. But why should we here on land worry about a few distant dying limestone metropolises? Because coral reefs are the rainforests of the ocean. Although they cover barely 0.1% of the seafloor, they provide a home for 25% of all marine species. If corals were to disappear, the marine food chain would collapse. threatening the food security of 1 billion people worldwide. Furthermore, reefs act as living breakwaters. Without them, tropical storms and tsunamis would sweep through coastal cities unopposed, causing staggering destruction. Coral reefs are also one of modern medicine's most important treasure troves. We developed the anti-leukemia drug, RAC, from sponges living on reefs, and a painkiller more effective than morphine from the venom of cone snails, and that's just the tip of the iceberg. Deep in the sea, countless undiscovered compounds may await us that we might never discover if the reefs vanish. The good news is that the process is not yet irreversible. Researchers are already working on breeding supercorals that can better withstand the heat. We can help too. By reducing our carbon footprint, we can slow down global warming, and by using reef-safe sunscreens, we can avoid poisoning the water with harmful chemicals. Remember, in nature, everything is interconnected. A creature the size of a pinhead can hold back the might of the ocean, but only if we take care of it. If you enjoyed this deep-sea adventure here at Zapnik's lab, don't forget to subscribe and check out our other videos. Science is for everyone, from age 4 to forever. Have a wonderful day, and stay curious. Bye, everyone.